So in this slide, we're going to learn to write the equations of a line. And so in the last lesson, we kind of understood the parts of the three different equations of a line. Now we're actually going to write it. So I guess one of the most important things to realize is when they ask you to write an equation of a line is, first of all, what form of the equation do they want? Do they want you to write it in slope-intercept form? Do they want you to write it in standard form? Or do they want you to write it in point-slope form? And so that's obviously super important to know, is what do they want the final answer to be written in? And second, what information is given? Because oftentimes you have to start with one to transition into the other. Okay, so we'll kind of go through it, and I'll come back to this slide if we need to. So here it says, find the equation of the line with the given information. So when they don't tell you a specific form in which they want, see, find the equation of a line. Now, they didn't tell you how they want it. I would say try to put the final answer into slope-intercept form, unless otherwise told, okay? So this will be kind of like the default, right? So when you come over to number one, you look at what's given to you. And you say, okay, well, they gave me the slope and they gave me the intercept. Well, obviously then I'm going to use slope-intercept form here. Y equals the slope is 3 and the intercept is 5. And so there's your answer. Easy. Now, when we get to number two, again, notice what's given. They gave us the slope and they gave us a point. Well, point-slope form would seem to make sense, point and slope, right? So point-slope form is y minus y1 equals m times x minus x1. And so, again, what happens is that this y and this x are going to stay those letters, okay? So what happens is this ordered pair becomes x1, y1, and the slope here is m. So when we come over to the equation, we're going to do y minus y1, which is 5, equals the slope times x minus x1, which is 4. Now, this is the answer in point-slope form. So if your teacher, wants it in point-slope form, you just have to put those three values in, and you don't have to do anything else, okay? You don't have to convert it to anything. However, most of the time, we're not going to say, hey, just leave it in that form. We're going to want you to put it in slope-intercept form. So how do we go from point-slope to slope-intercept? Super easy. You're going to start by distributing the -2 on the other side, -2x plus 8, and then you're going to add 5 to both sides. Remember, slope-intercept form is really just solving for y. So minus 2x plus 13. Now you have it in slope-intercept form. Again, same thing here. Notice that they gave you the slope, and you were given a point. And so, again, you're just going to plug it into point-slope form. So y minus 2 equals the slope times x minus -1. Again, minus negative is x plus 1, right? So if I was to want this in point-slope form, you would be done, okay? Now, again, we're going to convert it to slope-intercept, and we're going to do that by multiplying by that fraction. Now, here's one little tip here. I know that I just told you to distribute the -2 up here, and so one of the things you might want to do is distribute the -2/3. However, some of you guys don't love fractions too much, so one suggestion to you is to take that denominator of 3 and multiply everything by that 3. And I'll show you what happens when you do that. You're going to get 3y minus 6, and over here, when you multiply by 3, these 3's would cancel, and it would leave 2 times x plus 1. So you'll get 3y minus 6 is 2x plus 2. And again, we're trying to get slope-intercept form. So we're going to solve for y. We're going to add 6 to both sides. 3y equals 2x plus 8. And now you can divide everything by 3. So you're still going to end up with those fractions you would have ended up with initially, but you don't have to work with the fractions throughout. You can just deal with the fraction at the end. So multiplying by this 3 here is kind of saving you of that work, okay? Again, let's say you didn't want to do that. You know, let's say you're like, I don't really want to multiply everything by 3. That's completely fine. Let me show you how you would end up with the same answer, okay? You'd come over to here. You'd get y minus 2 equals 2/3 x plus 2/3. You would add 2 to both sides. You'd get y equals 2/3 x plus 2/3 plus 2. Now, if I want 2 to have a denominator of 6, or 3 rather, right? I'm going to have to multiply the bottom by 3 and the top by 3, so it's going to be 6/3. So notice it's y equals 2/3 x plus 8/3. Same answer we got. It's just more direct. Okay, we didn't do that extra multiplication. All right, and then the last one here, we have 2 points. So we've got a point and a point. Well, guess what? There's no point-point form of an equation. However, there's point-slope. So I have 2 points. I can pick whichever one, but I need to know the slope. So what I'm going to do is I'm going to write one on top of the other like I showed you the other day, and I'm going to identify the slope. Again, change in y over change in x. So I'm going to do top y minus bottom y over top x minus bottom x. So my slope's going to be -2 over -3, which is 2/3. So now I have my m value. It's positive 2/3. Now I can use point-slope form to come up with the equation. Now, which point do I use, this one or this one? Guess what? It's your choice. Okay, so I'm going to make this one x1, y1. And what I try to do is I try to avoid the ones that are negative. I try to avoid the ones that have fractions. So I try to pick the easiest xy combination. In this particular problem, they're both pretty easy, so it doesn't really matter, okay? 2/3 times x minus 2. And so now I have my setup. Again, this is the equation in point-slope form. And if I didn't tell you which form, if I said leave it in point-slope form, you would be done at this point. Because again, I want it in slope-intercept form. I'm going to do the strategy again where I'm going to actually multiply everything by 3, just because I kind of like doing that method better. So 3y minus 12, and then these would cancel, leaving me 2 times x minus 2. And I get 3y minus 12 equals 2x minus 4. Add 12 to both sides. So 3y equals 2x plus 8. And here I get y equals 2/3 x plus 8/3. So I know it's weird. The answer ends up being the exact same as the other equation, but I assure you that these are 2 separate problems. Okay, so now it says find the equation of a line with the given information. Now again, this is a horizontal line, and we're talking about vertical lines. So remember that in a horizontal line, it's a y equals something, and in a vertical line, it's an x equals something. So all you really have to do is come over here and look at the y value. Since the y value is 7, this is the equation of y equals 7. When I do a vertical line, I go to the x value, and it's x equals -1. It is that simple. As long as you memorize, you know, which one is the horizontal is the y equals, the vertical is the x equals, it really is no big deal. But, you know, I'm not a big fan of memorization, but in this case I am. Okay, now parallel and perpendicular lines also have a special relationship, okay? In lines, and in equations of lines, parallel lines have the same slope, okay? They have different y-intercepts, but they have the same slope, okay? Perpendicular lines have slopes that are opposite reciprocals, okay? We call it also negative reciprocals, however you want to refer to it. So what is a negative reciprocal? Well, if the slope of 1, okay, let's say slope of 1 is 2/3, the slope of the perpendicular to that, okay, is going to be the reciprocal, the reciprocal is the flipped, so it's going to be 3/2, and the opposite sign. So it'll be -3/2, okay? So if the slope is 4, well, we know that's the same as 4/1, so the perpendicular line would have a slope of -1/4. If this was -1/5, then this would be +5/1. okay? And so the perpendicular line, you flip it and you negate it, or you change the sign, okay? And again, parallel lines have the same slope. Now, because we know that parallel lines have the same slope, and we know that perpendicular lines have a slope that is the opposite reciprocal, we can solve all these questions just with that basic knowledge, and then of course understanding how to go from a point and a slope to an equation. So when I look here, I see that they want to know the equations of lines that are parallel and the equation of a line perpendicular to this particular line here. And they're telling you that it's parallel and perpendicular to that line, and the new lines for A and B also pass through this ordered pair. And so you're given a point, and what you need is a slope, right, to come up with the equation of a line. So the whole purpose of this equation that they give you is to identify the slope of this line, and by finding the slope of this line, you can then apply your skills to find the slope of the line parallel to it or the line perpendicular. So I'm going to start by finding the slope of this line. So it's 2x minus 3y equals 5. I'm going to add 2x or subtract 2x from both sides, and then I'm going to divide by negative 3. So I know that in slope-intercept form, I've got 2/3 x minus 5/3. The slope here of this line is 2/3. So the slope of a line parallel to it is going to be the same. It's going to be 2/3. And the slope of a line perpendicular to it is going to be the opposite reciprocal. So in A, when I go to find the equation of a line parallel to this one, I know that I'm going to use the point given, y minus negative 1 equals the same slope, 2/3, times x minus 2. And so I get y plus 1 equals 2/3 x minus 4/3. I'm going to subtract 1 from both sides, which is the same as subtracting 3/3. And I'm going to get y is 2/3 x minus 7/3. So this is an equation of a line that is parallel to that line. Now, when I'm trying to come up with a line that's perpendicular, I'm going to still use the same ordered pair, so y minus negative 1, but now I'm going to use negative 3/2 as my slope and x minus 2. So again, y plus 1 equals negative 3/2 x plus 6/2. And I'm going to subtract 1, which is the same as 2/2. So y equals negative 3/2 x plus 4/2, which simplifies to minus 3/2 x plus 2. And that's the equation of a line perpendicular to it. So again, the whole purpose of giving you this equation is just so you can identify the slope of that line and then either use the same slope for parallel or the opposite reciprocal for perpendicular. So we go to numbers. This is not really number 7. This is 8. And I guess this is 9. Okay. So in 8, again, they want a line parallel and a line perpendicular to this line that happens to go through this point. So let me just kind of change colors here. So I'm going to first find the slope of this line that they gave me. So that's all I'm going to use this line for. So minus 5x minus 3y equals minus 5x plus 8. And if I divide everything by negative 3, I'm going to get negative 5x over minus 3 plus 8 over minus 3. And all this simplifies to positive 5/3 x minus 8/3. So now I know that the slope of this line that they gave me is 5/3. Okay? So if I want a line parallel to that one, it's also going to be positive 5/3. And if I want a line perpendicular to it, it's going to be negative 3/5. So again, when I'm coming up with my equations, I'm going to do y minus 1 equals 5/3 times x minus negative 4. So y minus 1 equals, now remember minus a negative is like plus a positive, so it's going to be 5/3 x plus 20/3. And then I'm going to add 1 to both sides, which is 3/3. So my equation here is going to be y equals 5/3 x plus 23/3. That's A. And then for B, I'm going to do y minus 1, but now my slope is negative 3/5. Again, it's going to be x plus 4, because minus a negative, right? I'm going to add 1 to both sides when I'm done. Well, let me distribute first. Let's do that. So we're going to get y minus 1 equals negative 3/5 x minus 12 over 5. I add 1 to both sides, which is adding 5 over 5. And I get that y equals negative 3/5 x minus 7/5. And this is the equation for B. Now, the last step here in number 9 is to rewrite the answer from 8 in standard form. Now, there were 2 answers, so I'm going to do both. So I'm going to take the first answer for A, and I got y equals 5/3 x plus 23 over 3. Well, if I want it in standard form, I can't have any fractions, right? And x has to be positive. So I'm going to start by multiplying this whole thing by the LCD of 3. That'll give me 3y equals 5x plus 23. So denominators are gone. And then I know that x and y have to be on the same side, but if I bring x over here, it's going to be negative, right? So I can bring it over if I want. It'll be minus 5x plus 3y equals 23. But now I know that I have to multiply everything by a negative 1 because, again, x has to be positive. So I get 5x minus 3y equals negative 23. And that would be your answer there. And if I did the same thing for B, I've got y equals negative 3/5 x minus 7/5. Again, I have to eliminate denominators, so I'm going to multiply everything by the LCD. 5y equals minus 3x minus 7. I'm going to move the x to the left by adding 3x to both sides. And I'm going to get this, which is perfect. No fractions, and x is positive. And so now I've converted it to standard form. So again, you have to really get a mastery of slope-intercept form, which is great for graphing. Point slope, which is great for coming up with equations when you have just a point and a slope and you don't have the y-intercept. And then standard form, which is another really kind of a cool way to write an equation, and it is useful in some standardized tests. And again, there's some skills where you want it in standard form, and here you have it.